This video is for 7.8 Models Involving Rational Equations, Objective 4, Model and Solve Uniform Motion Problems. Remember that uniform motion refers to distance equals rate times time. We set a speed in our vehicle and we use that speed for some time. We multiply the speed by time. It tells us how far we go. Distance equals rate times time. For this chapter, we're going to be using something about the time. So instead of using d equals rt, we solve for the time by dividing both sides by the rate. And that says the time is distance divided by rate. So instead of doing distance equals rate times time at the top of our table, we will do time equals distance divided by rate. In this problem, we have a commercial jet that travels 1,620 miles in the same amount of time. That's the key phrase there that tells me to use the time formula as opposed to distance. In the same amount of time that it takes a corporate jet to travel 1,260 miles. So the two legs of the trip are corporate jet and commercial jet. So our commercial jet travels 1,620 miles in the same amount of time it takes a corporate jet to travel 1,260 miles. The commercial jet is 120 miles per hour greater, or has a speed that is 120 miles per hour greater or more than the speed of the corporate jet, x plus 120. So the formula says distance divided by rate, or 1,620, divided by my rate of x plus 120. And the rate, or the time for the corporate jet, is the distance divided by rate, 1,260 divided by x. And when we read back through this problem, we see that it takes the same amount of time for both of these two jets to travel. And so if it's the same time, we take these two times and we set them equal to each other. 1620 over x plus 120 equals 1260 over x. We like to solve these ones by taking the cross products. 1,620 times x equals 1,260 times x plus 120. I'd like to make these numbers smaller before I distribute. And so if we divide both sides by 10 right now, we'll get those numbers a little bit smaller, which is 162x equals 126 times x plus 120. I also see that I could divide both sides by 9. That's 18x, and that's 14 times x plus 120. You can divide them again by 2 to make them a little bit smaller. Now I have 9x equals 7 times x plus 120. All right, so that's 9x equals 7 times x plus 840. When I subtract 7x from both sides, I get 2x is 840 or x is equal to 420 miles per hour. So the corporate jet takes 420 miles per hour, and the commercial jet takes 120 miles an hour faster than that, which is 540 miles an hour. Okay, again, so when I read through the problem, I see the phrase "in the same amount of time." That leads me to use the formula time is distance divided by rate, as opposed to distance equals rate times time. Here's a practice problem for you guys to try. Sales executive drives 32 miles by car and then an additional 576 miles by plane. The plane was 9 times faster than the car, and the total time of the trip was 3 hours. That tells you how the times for the two trips are related. You will want to use time equals distance divided by rate. I encourage you to press pause on your video and work this problem out, get a solution, and come back and check it against mine. Now that you've had your chance to work on this problem, we have the car and we have the plane. The distance traveled by the car is 32 miles, and then 576 by plane. The plane was 9 times faster than the car. The car had some speed. The plane is 9 times faster than that. We use the time as distance divided by rate, 32 divided by r, and 576 divided by 9r. We use the fact that the total time of the trip was 3 hours. So we take those two times, 32 over r plus 576 over 9r equals 3. We'll solve that by clearing our fractions using an LCD of 9r. We'll take 9r times 32 over r plus 9r times 576 over 9r equals 9r times 3. Here the r will take the r. We'll have 9 times 32. Here the 9r's take the 9r, which is 576 remaining. And then 9r times 3 is 27r. 9 times 32 is 288. Plus 576 equals 27r. 288 plus 576 is 864 equals 27r. So we divide both sides by 27 to get r. 27 into 864. 2 times. It's too small, so 3 times. Remainder 5, bring down the 4. And 2 times 7 is 14. 2 times 2 is 4 plus 1 is 5. All right, so r is equal to 32. So the car is going 32 miles per hour, and the plane, well, the plane is going 9 times that. 9r is 9 times 32, 288 miles an hour. Okay, so another type we do was the plane with the wind and against the wind, or downwind and upwind. And so we did these a while ago where we said that if the plane can do X miles an hour by itself and the wind is Y miles an hour, then when we went with the wind, our rate was X plus Y. When we went against the wind, it was X minus Y. So we set up that same kind of table. With the wind or downwind and against the wind or up. A plane can fly 300 miles down the wind, so that's a distance of 300 miles, in the same time that it can travel 210 miles against or up the wind. Find the speed of the wind if the plane can fly 225 miles an hour in still air. So we're saying that the plane can do 225 miles an hour by itself. When it goes with, it's X plus Y. And when it goes against, it's 225 minus Y. So the time then is distance divided by rate. (300 over 225 plus Y), 210 over 225 minus Y. Now we look for those keywords. It says that this plane can do it in the same time so we set these two equal to each other. So there's our proportion, and we solve this one by taking the cross products. We'll take 300 times 225 minus Y equals 210 times 225 plus Y. Now remember, 300 and 210 are both divisible by 70. No, 30. I'm going to divide both sides by 30. 30 goes into 300 10 times. 30 goes into 210 7 times. Distributing the 10 across gives us 2,250 minus 10Y, and 7 times 225 is 1,575 plus 7Y. So we add 10Y to both sides and subtract 1,575. Which gives us 675. Dividing both sides by 17 gives us Y equals 675 over 17. And let's write this as a fraction. Three times 7 is 21. 3 times 1 is 3. 4, 5. That's 7 minus 1 is 6. 6 minus 5 is 1. Remainder 16. Bring down the 5. 17 goes into 165. I believe it's 9 times 7 is 63. 9 times 1 is 9. So 6 is 15. 5 minus 3 is 2. So 39 and 12/17. All right, so the wind is 39 and 12/17 miles per hour. All right, practice 6 is for you to try. Set up your table. Press pause on your video and come back when you're ready to see the solution. Now that you've had a chance to solve this, we have a small airplane that can travel 120 miles per hour in still air. The plane can fly 700 miles with the wind in the same time that it can travel 500 miles against the wind. All right, so we see that this 120 miles per hour in still air is a rate. So that's the plane. That's the plane's rate. And then it says when we go with the wind, we can do 700 miles. In the same time, when we go against the wind, we only get 500 miles. The plane can do 120 miles per hour by itself. That means when we go with the wind, the 120 gets added to whatever the wind is. But when we go against, the 120 miles per hour slows us down, or the wind slows the 120 miles per hour down. So the time going with the wind is 700 over 120 plus W, and the time against the wind is 500 over 120 minus W. And this is in the same time. So these have to be the same. 700 over 120 plus W equals 500 over 120 minus W. So we take the cross products. 500 times 120 plus W. 700 times 120 minus W. Makes it so much easier to divide by the greatest common factor, which is 100 in these cases. 100 there, 100 there. It leaves us with 5 times 120 plus W, 7 times 120 minus W. So we distribute the 5 across. That gives us 600. We distribute the 7 across, and that gives us 840. Adding 7W to both sides, 12W, subtracting 600, 240. We divide both sides by 12. 12 goes into 24, 2, so that gives us 20. So the wind speed is 20 miles per hour. This concludes the video on 7.8, Models Involving Rational Equations, Objective 4, Model and Solve Uniform Motion Problems.